Okay, so now we are on adding and subtracting rational expressions. Now, multiplying and dividing rational expressions is way easier than adding and subtracting them, unless we are in the situation that we have common denominators. So the nice thing is that when we have common denominators, and this is how I like to do it, I go 7x plus 1 plus 5x minus 3 all over 2x. So then I add these guys together and I get 12x minus 2 all over 2x. And then I can factor out a 2 from the top and 2x on the bottom. This crosses out, and that's what I'm left with. But I have an NPV that x cannot equal 0. Same thing here. We have x squared plus 3x minus 10 all over x minus 2. Have to factor, always have to simplify. So this is x plus 5 and x minus 2. So these guys cross out. And that leaves us with just x plus 5. But x cannot equal 2. Okay. 2x plus 8 all over x plus 4. X cannot equal negative 4. Factor out a 2. These guys cross out. So we're just left with 2. It's really satisfying sometimes when it works out so nicely. So 2a minus a plus 1, because negative, negative, all over b. And we get a plus 1 over b, where b cannot equal 0. So that was easy stuff. Next we have when we do not have common denominators. So the first thing is you have to kind of identify what each one is missing. So if we look at the one on the left here, this guy's just missing an x. So we're going to multiply by x to the top and to the bottom. When we look at this one now, it is 2x squared over x squared y. So we have the matching x squareds, but we're missing this y. So this guy has to multiply by y, top and bottom. So plus 4y. So now we can put it all over the same denominator. X cannot equal 0 and y cannot equal 0. This one is a little more complicated, which is fine. This guy is missing a 2 and a t, so we're going to multiply 2t. This guy is missing an s, and this guy is technically over 1, so he is missing a 4ts. And that gives us 2t minus s squared plus 24ts all over 4ts. And we can't simplify that any further, so state your NPVs. T cannot equal 0 and s cannot equal 0. Next set. It's very clear to see in this one that we are missing an x minus 3. So this becomes 1 minus 4x plus 12 all over x minus 3 multiplied by x plus 1. X cannot equal 3. X cannot equal negative 1. So this leaves me with negative 4x plus 13, and that can't be factored anymore. Not to anything that I can cancel out in the denominator, so I don't really care. 1. Okay, the greatest common factor between 6 and 4 is 12. So I'm going to multiply this guy by 2, this guy by 2, this guy by 3, and this guy by 3. So this gives me 2x minus 6 over 12 minus 3x plus 6. These guys cancel, and then I get negative x over 12 with no NPVs. Okay, and then our last one is when it is not factored. We cannot guarantee that we have the same denominator, so we need to check. So the first thing that you should do is you should always factor the denominators first. I don't really care about the numerator right now. So if I do this, this says y plus 2, y minus 2. So this guy is missing a y minus 2. So then that leaves us with y squared minus 20 plus y squared minus 4y plus 4 all over y plus 2, y minus 2. This top simplifies to 2y squared minus 4y minus 16 all over. I'm going to put empty brackets because I don't want to rewrite the denominator a couple dozen more times. The top factors down to, well, you can factor out a 2 here. So then that changes to 2. This changes to 8. So then that changes to y minus 4 and y plus 2. So then this would be y plus 2, y minus 2. These guys cancel. Our NPVs, y cannot equal plus or minus 2. So we're left with 2y minus 4 brackets over y minus 2. Next one, factor out the bottoms first. So our bottom factors down into x minus 7 and x plus, no, I'm running out of room again. So then that should be x minus 7, x minus 1. This is x plus 1, x minus 1. And then this guy is missing an x minus 7. And this guy is missing an x plus 1. So then that factor, that multiplies down to x cubed minus 49 x plus x squared minus 49 plus 2x minus 2x squared plus 14x minus 14 all over brackets. So then that leaves us with, simplified down, to x cubed plus 3x squared minus 33x minus 63. And at our current capabilities, that's where we're going to leave it because we don't know how to factor higher degree polynomials, but that's fine. We move on. Okay, first thing I'm going to do here is I'm going to factor out this negative. So this is now negative x plus 2, x minus 2. This one is x plus 2, x plus 2. So then we need to multiply by x plus 2 to this side. And an x minus 2 here. Because we'll move that negative up here. No, we're going to keep it down there, I lied. So then we need to multiply by a negative 1 here. So then that becomes 3x plus 6 minus, because this becomes negative x plus 2, minus 5x plus 10, all over negative x plus 2 squared x minus 2. And that gives me negative 2x plus 16 all over negative x plus 2 squared x minus 2 factor negative 2 x minus 8 all over negative x plus 2 squared x minus 2. And NPVs, x cannot equal plus or minus 2. Last one. First thing we're going to do is we're going to rewrite this guy because I know it looks wild and terrifying. So a over 25 minus a minus 5 divided by 1 over a. First thing we'll do is we'll flip this. So a over 25 minus a over 5 multiplied by a over 1. Identify what we're missing. We're missing a 5. And we're missing a 25. So this becomes bed mass. So do your multiplication first. So a over 25. Oh, wait a second. Do your multiplication first. So minus a squared over 5 times by 5 times by 5. So then that gives us negative 5a squared minus a over 25. We would factor out the negative 5 to give us negative 5a, so it would be a plus 1 over 25. This would cancel, so then you would have negative a plus 1 over 5. Yeah, looks good. All right, if you have any questions, please let me know. Again, go back, practice your factoring, make sure you're comfortable with that, and take your time, go slow.